What strategies can operators take to ensure their active equipment is running efficiently? How can understanding the strong and pain points in equipment help operators prevent significant failure? We'll hear insights into these questions and much more on this episode of Maintenance Shop Talk, a podcast presented by ExxonMobil. I'm your host, Michelle Siegrist, and today we'll be talking about how used oil analysis can help operators better understand lubricant and equipment performance. Joining us today is Jeffrey Folk, field engineer at ExxonMobil, and Ken Bannister, lubrication expert and published author on industrial maintenance. Ken and Jeff, welcome.
Hi, Michelle.
Hey, Michelle. Thanks for having us.
Of course. It's great to have you both here with us today. We'll dive right into our very important topic. So preventive maintenance can mean a lot of things around a plant. With regard to lubrication, what strategies are available?
Well, let's start off with preventive maintenance because that is probably the most predominant strategy there is. And when we talk about preventive maintenance with regards to oil, we're talking about restoring the oil back to its original condition. So there's a number of different ways we can do that. We can clean it and centrifuge it, we can filter it, and we can top it up with additives, or we can just replace it. So that's the basic strategy. Then we can get into the condition-based maintenance strategy. And oil analysis is all about checking the condition of the oil and the amount of degradation, but it also checks if there's any metal wear or particulates in the oil that are specific to the bearing surfaces. So it has a double edge on that one. And then, of course, we've got the predictive maintenance strategy that follows when you perform oil analysis a number of times. We can then start to get a trend of what is happening with the lubricant and with the bearing condition. So there are quite a number of different strategies, basic ones, but very, very effective that we can use.
And Jeff, what are some of the strategies that you use?
So, for example, a lot of times when you look at oil analysis, you can take learnings from the actual results. So you might, based on the results, if you see your oil is dirty, you may do some kind of a storage and handling audit to see how am I actually handling this oil before it goes into the machinery. You may look at your breathers or your filtration on that specific piece of machinery. So yeah, those are just some of the ways you can use it.
That's great. So taking that a little deeper, Jeff, can you explain to us exactly how used oil analysis works?
So basically, you want to set up a program where you take an oil sample from the machinery on a regular basis. And the goal of this is to establish some kind of a trend on how the machinery is operating. So you start out by taking a sample of the new oil in the system, and that's used to establish a baseline. Then you're going to, like I mentioned earlier, create these sampling routes as a part of your program. It might be the oilers, it might be the operators that are pulling these samples. There's a few different ways you can do it. You can use a vacuum pump. You can install sample valves. That tends to be the best, most repeatable method. Finally, once you have these results, once you send them off to a good lab, you're going to look at the key indicators from these reports. Those are usually viscosity, water content, metals, things along those lines.
So based on the assessment that you get from the used oil analysis, Ken, what are the types of insights that can be derived through that program?
That's a good question. I guess the easiest way to explain that, Michelle, is oil analysis is very much like when we look at our own selves, is like a blood sample. I mean, we've all been to the nurse or to the doctor and they've sort of siphoned the blood. Jeff was talking about a siphon pump there. They've siphoned it out of us with a needle and then off it goes to a magic laboratory and it's tested. And it's very, very similar in that respect. They're looking for anomalies within the blood. They're looking for the viscosity, the thickness of the blood. They're looking for anything that's in there. For instance, you may have cholesterol, you may have anemia, or you may have a low cell count. So they're counting things just like you would inside of an oil sample. And then in the end, you either get a top up with platelets or something like that, or you get a transfusion, get a full oil change. Well, it's very much similar when we look at oil samples themselves. The oil sample really lets us look inside the equipment and what is actually happening. And it really is the lifeblood of the machine. So we're looking for things like water, for metals and additives that don't meet to the same criteria as the new sample, which Jeff was talking about. And then we're also looking for contaminants, the really bad stuff, the silica. And when we put that in perspective, when we're looking for the insight on that, it tells us by understanding what we're doing in our facility. So for instance, if we're with food, we expect to see a little bit of water in bearings every now and again through the washing process. In a pharmaceutical, we don't expect to see that at all. So that's a bad thing. And similarly, if we were in, say, a foundry, we would expect to see a lot of silica or sand creeping into the lubricant and thickening it up. Where, again, in a pharmaceutical where we have HEPA filters, that's not a good thing. Or in a food plant, we don't want dirt around. So it gives us insight in many different ways, and it depends on the work environment and the ambient condition factors. Once we know those, we can tell whether it's an operational problem, whether it's an equipment problem, or it's an oil problem.
Well, I love those analogies. It's really interesting how much detail can be derived. And so based on that, Jeff, how can we qualify these insights?
Yeah, so I tend to think of it in three separate categories of insights that we can take away from oil analysis. I split it out into equipment health, oil condition, and then contaminant status of what contaminants are in the oil. What I mean by equipment health is what condition is your equipment in? Do you see iron? Do you see copper in the oil analysis results? To go back to Ken's example of the blood test, like when I go get a blood test, I might have high triglycerides. It might tell me what condition my body is in. Now, I guess in the ideal world, I would modify my diet to change that, but that's another story. But the second category would be the oil condition. So what is the actual condition of the oil? Does it need to be changed? Is it oxidized? Has it lived its useful life? And then finally, contaminant status is what Ken was alluding to earlier with water, particulate contaminants, and things like that, that really, a contaminant is anything that is in the oil that should not be in the oil.
Okay, great information. That's very helpful. And so taking that a step further, now that the operators have these insights, how can they actually apply this knowledge to improve the performance of their equipment?
Yeah, this is really the most interesting part of all of this because anybody can get the data, but the data is really just evidence in this case. It's kind of like a fingerprint. And once you get the data, you become the detective. So you need to take that evidence that you just got from the oil analysis, and you need to combine it with vibration analysis, with maintenance history, other pieces of evidence to put the whole story together. One example that I can think of recently, actually, with a customer, this was a few years ago, I had a customer that was continually getting sodium in their oil analysis results. And they kept saying, where is the sodium coming from? We don't have any coolant on this. Could not figure it out. So you take that piece of evidence and go out and talk to the operators and come to find out that these operators are using some type of a solvent, some type of a cleaner to clean off this gearbox. And so what's happening is that is getting into the oil. And anytime you have a contaminant in the oil, you can't really predict what's going to happen to the additives. Are you going to get additive dropout, things like that? So the oil analysis was really just the start. Once you become the detective, you put it all together and build a story for a corrective action.
That's a great example. I love hearing that. It really shows how this used oil analysis can be put into action. Do you have anything to add to that, Ken?
Well, I mean, there's lots of things where you see, especially when lids are left off, the breathers are not in place properly, or you'll get residual fallout from the production process. And as Jeff says, it really is the detective side that comes into play when you put that against the original baseline of the oil. It tells you what shouldn't be there and at what levels in the oil itself. So you really do have to put on your Meerschaum pipe and put the deerstalker on and go looking. But it's not as difficult as you think. As Jeff says, you just talk to the right people, and especially the operator. And the operator knows when the machine is on the sweet spot and when it's not. And it's just up to the maintenance guy to ask, and he or she will be more than happy to tell you. They may not be articulate, but that's what the sample does. It articulates it for you. And as we saw in Jeff's story there, it comes to light very, very quickly.
Once that detective work happens and you identify the issue, then it's pretty easy to correct after that. Am I hearing that correctly?
Yeah, there are certainly sometimes you can correct it and sometimes you can't. If you're in the middle of a paper mill and you have water dripping directly onto a gearbox, you may not be able to correct that, but at least you understand what's going on.
Especially if you're in the Ford Rainier section there, right?
That's right.
Well, yeah. I'm sure that used oil analysis has changed through the years, and especially through the use of digital technology. So perhaps you could tell us some of the different types of technology that are available, and how has this improved the quality of the used oil analysis test?
I'll take that one, Michelle. I guess where we're leaning to these days is the world of big data. And I'm sure everyone out there has heard of the Internet of Things, the industrial Internet of Things. I think we're in version 4.0 now. And this is Oil analysis, as Jeff alluded to earlier on, is only one piece of the pie. You've got thermography, you've got vibration analysis, and you've got your maintenance history that all come together. Now, in the world of big data, all of that is collected, and it's actually the raw data is put into what's called a data lake. And then we can mine that data lake and it brings it back. And through algorithms, they're used to compare and contrast to other machine behavioral tendencies. And then what that does, it allows the machine analytics in themselves to actually look and recognize certain conditions against certain data sets. And the machine gets smarter and smarter and smarter the more data it collects and the more trends it starts to see. And then all we have to do is take these very accurate prescriptions and actually do something with them. Now, that's the weakest link in the chain right there. We've got technology working for us, but like they say, you can take a horse to water, but you can't make it drink, right? If you get an alarm state, if you get that prescription that says do something specifically, if we don't do that and get a catastrophic failure, then shame on us. So we are the weakest link there, but the digital technology today is becoming really exciting and really fabulous, and oil analysis is a definitive part of that.
And the point is that the digital tools are available now, and there are many advancements. Wouldn't you say, Jeff?
Yeah, absolutely. To kind of build on what Ken was saying on the machine learning side, one thing that we've done here at Mobil to try to make the data more accurate that is feeding into this machine learning pipeline is to introduce what we call scan and go technology. So one thing we've been doing is putting QR codes on our oil sample bottles and putting QR codes on the machine or the asset that's being sampled. So the person out in the field is not fiddling around with labels or writing on the top of the bottle with a Sharpie, things like that. Whenever you have something like that, you introduce a lot of human error. So with just a smartphone, you're able to scan the bottle, scan the machine, and pair them that way. So reducing the human error there and making it easier on the person pulling the samples goes a long way towards improving the quality of your results.
Well, we really have come a long way, haven't we? I really want to thank Ken and Jeff for this extraordinarily interesting conversation. This has been great information.
But that is all the time we have for today's episode. Please be sure to check back for new episodes of Maintenance Shop Talk, a podcast presented by ExxonMobil. And for more information about how to maintain and properly lubricate your equipment, please be sure to visit mobil.com/podcast. Please tune in next time, and thanks so much for listening.